Hello class, this is a video tutorial on expressing quantities as a rate. Rates are a comparison of different kinds of quantities. Unlike ratios, rates have units of measurements. And rates are often expressed as a unitary rate of one quantity. You'll see what we mean about this in a moment. So I want you to remember how ratios was merely 3:2, 4:5. Right, in those examples that I just said, there was no units of measurement. So for example, ratios have just 4:5, 3:2, etc. Rates are not the same. We'll take a look at what we mean in this example right now. So a car travels 420 kilograms in 3.5 hours. So the rate for this is going to be, we can calculate it very simply, 420 kilometers over 3.5 hours. So we're going to express kilometers for every hour. Okay, so that means we can type this in. Whoops, running out of battery. There we go. 420 divided by 3.5. This gives us, so this number that we see here in the top, it will be 120 kilometers per 1 hour. Or we can express this in the way that we normally see it, 120 kilometers per hour for every 1 hour. Take a look now. So Colin is paid $71.25 for working 9.5 hours. So we can calculate this rate is equal to the first amount, $71.25, divided by 9.5 hours. You can type this in as 71.25 divided by 9.5. This will give us $7.5 per 1 hour. Well, we can express this the way that we normally see it. $7.50 per hour. Or you can just leave it as a H if you'd like. Okay. 25 kilograms of potatoes was sold for 66.24. Now in this one, okay, I want you to take this, see if it's going to be either 24 kilograms over $66.24. Is this the rate? Or is it the other way around? Going to be $66.24 divided by 24 kilograms. I want you to think, is it this first one or the second one? Now let's just follow both of them and see which one makes the most sense. So let's type this one in first. 24 over 66.24. This gives us what does it actually mean? This would be 0.3623 kilograms for every what? Well, this is for every $1. Now let's take a look at this one. 66.24 divided by 24. This gives us this amount that we see is the one that's on top, so $2.76 per 1 kilogram. Let's write these out. That way we normally see them. So 0.362 kilograms per dollar. Or do we see this as $2.76 per kilogram? Well, when it comes to measuring fruit and veg, we normally see the per kilogram value. Let's do one last one here. Same question. Is the rate going to be 40.5 divided by 9, sorry, that's 40.5 kilograms divided by 9 meters square, or is it the other way around? Or is the rate equal to 9 meters squared over 40.5 kilograms? Let's see which one. Let's follow both and see let's see what it says. 40.5 divided by or over 9. This is 4.5 kilograms per meter squared. And this one, let's switch these around. 9 over 40.5. This will give us 0.22 recurring meter squared per kilogram. Well, normally it's per meter squared. It's how many seeds we can cover per meter squared. So the correct one would actually be this. Although there's nothing wrong with expressing things as per dollar. So for example, if I had $1, I could buy 0.362 kilograms of potatoes. But if I wanted 1 kilogram of potatoes, I need $2.76, $2.76. So in this one, what this is saying, if I had 1 square meter of soil, I need 4.5 kilograms to fully cover it. But if I had 1 kilogram per kilo, if I had 1 kilogram of seed, I could cover 0.22 meters squared of soil. So both of these indicate some sort of rate. It's just that some rates are more used than others. In any case, that's an insight into expressing quantities as a rate. Best of luck.